Okay, so in the last video we had seen that if sigma naught is a permutation on k plus L elements, 1 to k plus L, which takes 1 to k plus 1, 2 to k plus 2, L to k plus L, and then L plus 1 to 1, etc., and k plus L to k. So it is interchanging these two blocks, namely the blocks 1 to k and the blocks k plus 1 to k plus L. Then the sign of sigma naught is minus 1 to the kn. Okay? So, let's take T tensor S. So, plane. Let S in L K and T in L okay, and I want to say that what is the relationship between Fn so let S in Lk and T in LL. Okay? So let me write down T tensor S upper sigma naught, T tensor S upper sigma naught of V1. How many V's should I put in? I should put in K plus L V's. So V K, V K plus 1, V K L. This is equal to T tensor S of V of sigma 1, V now what does sigma do to 1 to k plus L? This is equal to of sigma 1 is k plus 1. It is interchanging these two blocks is what sigma does. So this is equal to and this is equal to so what we have proved here is that T tensor S tensor T. So there is a relationship between T tensor S and S tensor T. When you apply this upper sigma naught, then T tensor S becomes S tensor T. Using this, we will immediately be able to show that one of the properties about so we have one of the properties about the wedge product. Recall what is Yes? What is the definition of alt? Yes? And now what I'll do is, I'm going to change variables. Okay? When sigma, I'm going to call sigma prime equal to let sigma prime be equal to sigma times sigma naught, where sigma naught is the same permutation that we have just been talking about. So this is a change of variables. When sigma varies over all of sk plus L, sigma prime also varies over all of sk plus L. So this is equal to, I'll keep this the same. This will be summation sigma prime in sk plus L. And sine of sigma. Sine of sigma, sigma is sigma prime into sigma naught inverse. Therefore, sine of sigma is sine of sigma prime. Then sigma naught inverse. And here I have sigma is equal to sigma naught. But this quantity is equal to all these things. Remember, sine of sigma naught prime, sine of the inverse of a permutation is the same as the sine of the permutation. And we have just said that the sine of sigma naught is minus 1 to the kl. And anything upper sigma, sigma naught is equal to, you must first take sigma naught and then take sigma. But omega tensor eta upper sigma naught that is exactly what I have here. This is equal to, I have to interchange the order of what I have there. That quantity is equal to eta tensor omega upper sigma prime, sigma naught, prime, sigma prime. And this by definition is that minus 1 to the kl. What I have inside there is actually all these terms into what I have inside that is actually alt of eta tensor omega with the right factor in front. And into which is equal to so what this is saying is that when you interchange two terms in a wedge product, you get a minus sign out. This is exactly what we meant by this alternating, something to do with, it's not a minus sign, it is minus 1 to the k times L. Okay? So what we have is that omega wedge eta is eta wedge omega into minus 1 to the k times L.